Hello everyone. Thank you so much for being here today. I believe it is evening for you as well. I'm in the Eastern Standard Time, so um, it's a great honor to be here. And thank you, Deepankar, for giving me this great opportunity to present for your user group. So today I'm going to talk about the SQL Server 2022 and what all features we have, and I will touch most of the like performance tuning features that are available where like with if your database is in SQL Server 2022, then and also if you are on the um, SQL Server 2022 compatibility level, then these features are automatically turned on. But you need to know like how they work and like what are they. So I will be touching on all of them, especially regarding the SQL Server 2022. A little bit about me. I'm a database administrator having about like 8 years, 9 years of experience as a database administrator. And also I'm a data platform MVP. And also I did my master's in computer technology here in United States. And also I do volunteer work for data community. I'm a co-organizer for Data and AI South Florida user group and Diversity, Equity, Inclusion user group, and also Data TGIF. Thank God it's Friday user group. So apart from all of these, I love plants, arts, and crafts, and also spending some time with my kids. If you have any questions later and you are not comfortable asking here in the session, you can definitely contact me on DBA Nuggets, which is my Twitter ID. And I have my own blog post, like I do blogging, mostly about like SQL Server as well as Azure SQL. So you can go through my website over there, or you can contact me on LinkedIn. Like I'm very active on LinkedIn. I probably respond to you quicker if you can message me on LinkedIn. So it will be a nice thing if you can get in touch with me. You can also see what all like next upcoming sessions that I give. I usually post on LinkedIn couple of weeks before I'm presenting. So you can also um, see me on LinkedIn. So what is the main agenda of this session is like query store is a big thing in SQL Server because it got introduced. This query store feature got introduced in SQL Server 2016. Like if you have SQL Server, then you will automatically get query store feature. It is not like you buy query store feature additionally. So this query store feature have been there since SQL Server 2016, but they keep on adding the latest features to it. So with the SQL Server 2022, we are going to have query store hints, something known as hints, where they are similar like the query hints that you use within your store procedures, but this is a little bit different. This is like using hints within the query store feature, um, and you use the query store functionality to enable these hints. So we are going to talk about that. And also there are a couple of more IQP features that we are going to talk in this session, like parameter sensitive plan optimization, memory grant feedback, DOP feedback, and cardinality estimation feedback. Um, all of these last four things that you are seeing, these are the intelligent query processing features, um, which are um, which are advanced in SQL Server 2022. Like if they have been there before, but then these are like advanced. So apart from the parameter sensitive plan optimization, rest all the other bottom three things that you are seeing, the IQP features, require query store to be turned on. And in SQL Server 2022, query store is automatically turned on. They made it as a default. Like if you want to stop it, like if you want to disable it, you can force it. But it is, if you are creating a new database, then query store is automatically turned on. So only the parameter sensitive plan optimization doesn't require query store, but the rest of the other things require it. So before moving further, because all of these features are um, linked to query store, we need to actually know how query store works behind the scenes. So this looks a little bit complicated, but I thought like I can put this together as a picture, like as a flow chart, so that you will understand easily like how it works behind the scenes. So anytime, like let's say you have a query and you are on 2016 SQL Server 2016 or above version, and let's say you have a query, you enable the query store on the database, and you are running a query on that particular database, right? How does it act? Like, how does the query store act when a query runs on the database where it is enabled, right? So first, the query, um, even if it is enabled, like if the query is running on a database, if it is enabled for the query store or not, the process is like any query running on the SQL server, right? It will first, whenever it runs, the first thing that the SQL engine will check is like whether that query is running for the first time or it is running multiple times, right? But if it is running for the first time, then it will go through the compilation and optimization phases to generate an execution plan so that it can produce results, right? It can show us the results. But if it is not running for the first time, then the optimization and the compilation phase must have completed and a plan could have already saved in the plan cache. So if that is the case, then it will go ahead and see if there is a plan already in the cache. You may be having a question now. Well, this query has been running multiple times, and and there should be the plan in the cache, right? For sure, it should be. But there are certain scenarios where, even though your plan is saved in the cache, there are some certain scenarios where it will give evicted out of the cache. Like if, for example, if there is a memory pressure, or like the first thing that will happen when there is a memory pressure on SQL Server is like it will go ahead and evict the old unused plans. It will make some calculations on it, and it will see like what are the old plans that are not being used recently, and it will evict those so that it can have some memory for the queries to run. So that is the first thing that happens. If that is not the case, then there are a couple of other scenarios where this will happen. Is, for example, if you restarted your SQL Server, that will evict all the plans out of the cache, and the next time the query runs, it have to build a new plan. So there might be several cases where the plan can be evicted out of the cache. So if that is the case, right, if it didn't find the plan in the cache, then it will again go through the compilation and optimization phases, and then it will generate a new plan. But let's say it is already there in the cache, right? Then all right, it will go ahead and take that same plan from the cache. But before moving further, since we actually enable the query store on that database, it will do an additional step. So what does it do? It will check for the recompilation. So what is this recompilation? Recompilation is nothing but it will go ahead and check whether the plan that has been actually created or taken from the cache. It can be either scenario, right? It can be created or it can be taken from the cache. Is it similar to the plan that is being forced? So we enable the plan, we enable the query store on the database, and this query is running. Let's say this query, we have actually gathered some information in the query store, and we thought a certain plan is better than the other plan, and we forced that plan. So what is this forcing a plan, right? It's one of the advantage of query store, where you can compare the plans, different execution plans, and if you think one plan is better than other, you can go ahead and force the plan. That is just one advantage of query store. So let's say this query that we are running now, right? We actually forced a plan. So in this compilation, in this recompilation step, like check for recompilation, it will go ahead and see. So now I took a plan from the cache. Is it similar to the plan that I have actually forced? If it is similar, then it will go ahead and move further. But if it is not similar, right? Again, there are many situations where even though you force a plan, it can generate an entirely new plan, which is not related to the forced plan. Like for example, um, the plan that you actually forced, some developer went ahead and deleted an index which is used in that forced plan. In that case, that plan which you forced will be invalidated because there is no object which is being used in that plan, right? There is this index which is actually used, but this developer went ahead and deleted it. And so SQL Server things like, I actually forced a plan, but that plan is not similar right now, on not all the objects are in there. So what I will do is I'll build a new plan, and that plan is not at all similar to the force plan. So in that case, it will, what it will do is like, no matter if it is like similar or not, I will go ahead and apply that force plan. But if it is similar, then it will move forward with the same operation to produce the results. So after this, like after this step, right, it will move ahead and it will go ahead and save the query text and the query plan um, in a store known as plan store. And this, whenever you enable the query store on the database, there are two stores that will be enabled inside the memory. One is known as a plan store, and the other one is known as a runtime start store. So the work of the plan store is, it will capture the query text and query plan before even the query going to the execution phase. It will first capture that. And this process will happen asynchronously in the memory, right? Because these two stores will be enabled. Then the query goes to the execution phase, and then once the query gets executed, then runtime stat store will be captured, and that will be put in the memory as well. And this process happens asynchronously. And eventually, all of this collected data in the memory have to be pushed onto the disk. So where does this data get stored? Like once you enable the query store, all the query store information that is being captured will always be stored on the primary data file of the database itself. Wherever you are enabling the query store, it will always save all the information within that primary data file. Now, if you have multiple secondary data files and you want to save there, it won't allow you because the only way it can store is on the primary data file of the database itself. So eventually, it will end up in the system tables on the database itself. Again, this process will happen asynchronously, and it will be doing this as a set of intervals. So it depends upon what interval you have set. By default, it is every 15 minutes. It will push all the data that is being captured in the memory onto the disk. Again, it's on the primary data file of the database. I see a
Deepthi,
hand
yeah,
raise.
yes.
Yeah.
So first I have a question, then I think Chakshu also have another question. My question is, we're using Azure SQL DB, and by default, I'm assuming query store is default enabled.
Yes.
However, as you mentioned on the left side in the diagram, there is a, is plan is the force or not. You can actually do it, apply force. How it has been done in Azure case? Is it like automatically everything managed, or?
That's a very good question, Deepankar. So, when you are in the Azure SQL DB, there is another level of like advancement to the query store where there is um, like the normal advantage is to like you can manually force a plan, but as you are in the Azure SQL database in Azure, you have automatic plan correction. Like once you enable the query store onto the database, right, it is automatically enabled by the way. And that automatic plan correction will actually keep on monitoring about the it will keep on monitoring the queries as well as the plans, and it will always check like right now I have a plan which is good, so it will force the plan, and it will always check for the degradation of the plan. Like if there is a another plan which is not performing well, it will always make sure the last good plan is always turned on. But if it finds like any better plan than before, then it will go ahead and like unforce and force that new plan. So
Uh,
that is the advantage you have in Azure SQL DB, as well as if you are in enterprise edition of SQL Server, the latest enterprise edition of SQL Server 2019 and above, you have that option as well.
Okay. Yeah, thanks a lot, Deepthi. It's very helpful. I think Chakshu, you're gonna go ahead and ask the question.
Yeah, thank you, Divankar. So, Deepti, the question is related to the plan. When you say plan in Cashier or plan, so are we talking about the execution plan that we see in the SQL, which is more specific, like having a flow chart where it says that in the select query, how the query outlines uh, that how it's going to retrieve the data, basically.
Yes,
Like,
yes. It's
okay,
a exact execution plan. Um,
okay.
it
So
but it will always save the estimated execution plan, not the actual execution plan.
okay, so when we say the plan store, and
Mm-hmm.
there is a there is also you have mentioned query plan. What is the difference between plan store and query plan? I'm just a little
Um,
bit confused with these two
yeah,
terminologies.
sorry. This plan store doesn't exist if you do not have the query store enabled on the database. So they what they did was like um, when we enable the query store, there should be a way that all the data that is being captured to save in the memory first and then go from the memory to disk. So what they did is instead of using the general memory that we have for the SQL Server, which is like a plan cache, you know the plan cache, right? If you do not have the query store and you have the SQL Server, general SQL Server, you have a plan cache in the memory where all of your plans will be saved in that cache, like store procedure cache, and you have all of it. But with the query store, you have separate stores that gets enabled automatically once you enable the query store. And one of the memory is plan store. So this plan store will be actually allocated automatically when the query store is enabled. So that's a part of memory. So it is a in memory plan store, right? But
Okay,
the query plan is the plan itself, like how the query gets executed. Like for example, what are the operating operators it is being used? Is it using the seek, scan, or like you see the execution plan in your management studio, right? That's the query plan.
okay. So whenever we try to modify a query based on like whatever kind of response we get from the query, we try to uh, make it. I mean, whatever whenever we try to improvise the query, we always improvise the query plan because we have no control on plan store, right? Because that's a memory area.
Yeah,
It,
but you can always check you can always pull in the plan from the cache, from
okay,
the plan cache.
okay, okay, got it.
And then,
Okay,
like, sometimes what we do is we manually go ahead and delete a certain plan from the cache. We have the ability to do it. I think you need some permissions to do it. Like DBAs have that
hmm,
permissions. Like if a plan is
okay.
not working well, then we will manually go ahead and only delete that particular plan.
So
So
it's
with the
more like a
query,
session. It's more like a session, right? We can kill the session whenever I have seen the DBS have done this within the Oracle database. I haven't seen it in the SQL Server though.
mm. So
They kill the session. Yeah.
when you kill a
Mhm.
session, that session only will stop, but the cache that is being saved, the plan cache, how the query have to run, that cache will always be saved in the plan cache. And to evict it, either you have to clear out the cache. There are certain queries like free proc cache, or like you can use the free proc cache only on one particular query. You can also do that. Like if you are using a
Okay.
store procedure, you can mention you can mention some parameters and only delete that plan related to that store procedure instead of like deleting everything. It's not at all recommended to delete
Okay.
everything from the cache.
And last thing is this cache is at the client side, right? Or the server side?
The server side,
Okay, got it.
there is a
Thank you.
pool. There is a application pool from application side.
Got it.
Um,
Okay,
but then this is the what we are talking today is like a SQL Server plan cache from the server
got it.
side.
Yeah. Right,
the
right.
the topology, the methodology between Oracle and SQL Server are exactly the same, but
Mhm.
the how we call it might be a little bit different.
Different. Okay. Correct. Thank you.
No problem. Any more questions before moving forward?
We're good. We're good. Please go
Okay,
ahead.
good, good. Um, okay, so plan cache versus query store. So when we do not have query store turned on, we will definitely have a plan cache. Even though we have query store turned on, there is also plan cache already there. The query store caches are different. They are additional. So um, what is the difference between both of them? Like you might be asking a question. So when we have the plan cache, why do we have to have the query store? Then what is the difference, right? So inside the plan cache, whenever you restart the SQL Server, this plan cache, all the plans will be evicted out of the cache automatically. But with the query store, it doesn't happen. It retain all the data. It is being captured, and based upon the cleanup policy, which is like by default 30 days. Until the 30 days, it will save the data, and after 30 days, it will go ahead and delete the old data. So that's how it works with query store. And with the somebody is waiting in the lobby. Okay. And with the plan cache, we can get the latest plans out of the plan cache. We can't get the history of the plan cache because whenever we restart, it will go ahead and create the new plans again. All the plans will be lost. So it will go ahead and we can only get the latest plans. But with the query store, as it collects the execution plans over time, you can go back and see what was your last execution plan. And whenever there is a memory pressure on SQL Server, the first thing that it will do is to go ahead and delete the old plans from the plan cache. And that is a standard procedure, by the way. And with the query store, all the data that is being captured, right, we have seen in the diagram, it will capture the information in the memory, in those memory stores, and then it will flush out to the disk once the flush out interval reaches. Like by default, it is 15 minutes, but sometimes if there is so many queries are running and then there is a memory pressure, then it might go ahead and flush out to disk a little bit before it reaches the interval, and that's the normal procedure. And it is very difficult to know with plan cache why the plan has changed. All you can do is you can go ahead and pull up the latest plan from the plan cache, but how do you figure out why the plan has changed? What caused the plan to change, right? But with query store, everything is saved, and you can literally see like see and compare the old and the new plan, so that you can understand what changes have happened and make decisions based upon it. And that will become like easier to troubleshoot your problems. So what are the query store advancements in SQL Server 2022? It is enabled by default, number one. If you do not like it, you can disable, and you can force it to be disabled. And um, it, so whenever you migrate the databases, right, from the older versions to the newer versions, and your older version already have query store enabled on it, because this feature has been there since SQL Server 2016. So if your old database have a query store enabled and you move that database to SQL Server 2022, then it will not make any changes. And if your old environment do not have query store and you move to SQL Server 2022, then it will not automatically turn on the query store. It won't do that. It will give you an option to choose the query store. But if you create a new database on SQL Server 2022, then it will automatically enable query store. And with the SQL Server 2022, they have actually made some internal memory limits for the ad hoc workloads. So previously, there is no limit for the ad hoc workloads. You know ad hoc workloads, right? Like uh, the query do not have the specific um, like it is not a stored procedure. It is like an ad hoc query where the IDs change all the time, the query IDs change all the time, and that will actually fill up your query store very quick, and your query store can go to the read only mode once it gets filled. So to address that problem, Microsoft has actually created a memory limit for these ad hoc workloads. And there are also some queries in Microsoft Docs, like you can only delete these ad hoc workloads from Query Store regularly. Like, for example, you can create a SQL agent job and run that query on schedule so that it will automatically delete the ad hoc workloads from your Query Store. And the other advantage is Query Store hints. So let me go ahead and show you how the Query Store hints actually work. So I'm using the uh, what am I using? Am I connected to the Azure SQL database? Let me see. I have a problem with connecting to this server. I don't know why, but um, yeah, I have a problem with this, but I can share a video where I have talked about the query store hints specifically, because I have today I'm having problems. We changed our internet, maybe that is a problem, but I couldn't connect to my Azure SQL database for some reason. So I'm skipping this demo, but I'm going to talk about the other demo. But let's move forward mm, with the next steps, right? The intelligent query processing. So these are all the intelligent query processing features that we have for SQL Server. Based upon the color, you can see like the sea green color is for the SQL Server 2017, and the white mode is for SQL Server 2019, and the blue represents SQL Server 2022. So all the features that you are seeing here, they introduced them in SQL Server 2022. So I'm going to talk about most of them today. And first, we are going to talk about parameter sensitive plan optimization. This is the only IQP feature that doesn't require query store. Rest all of them will require query store. So the highlights were like, what are the highlights for this IQP features is like you do not have to make any code changes. All you have to do is like you need to make sure the database is on like 2022 compatibility mode. And once you do that, once you upgrade that, then all of these IQP features will work together. It is not like when one IQP feature is working, the other will go to sleep, but these all can work together. And then all of these IQP features can improve the performance of your queries as well. Like I mentioned, the query store advancements are it is enabled by default, and there is something else we need to remember is like before SQL Server 2022, there was this big issue where like how does the query store will work on the secondary replicas, because secondary replica is read only, right? So how does that workload on the secondary replica, which is read only, will capture the information because it is read only? How does it do? So there was no, that option was not there previously. But in SQL Server 2022, they added some technique. If you are using the availability groups and you have a secondary replica, which is on read only mode, the primary replica is the like it will lead the query store data. So all the data will be captured on the primary replica, and the data that is being captured on the secondary will be transferred to the primary using the same technique how the data will be transferred from primary to secondary. So in always on availability groups, the data is transferred from primary to secondary. So it will use the same channel, same exact channel to send the data from the read-only replica to the primary replica, and it will save the data on the primary data file of the database where you enable the query store. That's how it will be capturing when you use the secondary replica. And like I said, query store hints, I will definitely share the video with you. I have given the video and I have given the presentation before, so you can see those query store hints demo. I apologize again. I have no idea why I couldn't connect. So the next one is parameter sensitive plan optimization, and all of these additional IQP features we have, and these all IQP features um, will be will be using the query store except the PSP optimization, which is also known as parameter sensitive plan optimization. So let's talk about the parameter sensitive optimization, right? This is a little bit interesting. It is also known as PSP optimization, and it doesn't depend upon query store. There is something got introduced with this particular IQP feature known as dispatcher and variant plans. I'm going to talk about these two in the next slide. So, dispatcher plan is where the logic is stored, and variant plan is nothing but the query plan itself, like the execution plan itself. So, the thing is, like, let's say you have a query which is parameterized, which is very sensitive, right? Let's say you have a store procedure, and you give a parameter value while executing. Let's say so with one parameter, it produces like around 1,000 rows, let's say, and with another parameter, it produces like 2 million rows. There is a lot of difference, right? And that says like that particular store procedure is parameter sensitive. So if we are running a parameter sensitive query, let's say store procedure, with SQL Server 2022, there is something additionally known as dispatcher plan. This dispatcher plan is nothing but it holds the logic where like if you remember the SQL Server indexes as index tree, it will store the logic on the top of the tree, and then the all the below tree level will actually say where it have to go ahead and collect the data. In the similar way, dispatcher plan will have the logic to tell which execution plan it have to use. So with PSP optimization, SQL Server will not only store one execution plan in the plan cache, but it will store up to three execution plan in the plan cache based upon the results that you are getting out of that store procedure. Let's say you are running a store procedure which have agent less than 10,000 listings, let's say, and the results are less than 10,000 records that you are seeing. Then this dispatcher plan will have a logic which says, hey, as this execution only gets 10,000 rows, go ahead and just use the plan seek and look up and just give a small memory grant. But if it is more than 10,000 but less than 1 million listings, then go ahead and use the scan and medium memory grant. And if it is above 1 million listings, then go ahead and use scan as well as like large memory grant. So while it while the query gets executed couple of times, it will make these estimates, and then it will create up to three execution plans based upon your data. It will analyze the data and it will store up to three dispatcher plans. And based upon the results, it will go ahead and choose the same, like the best execution plan. Now, before SQL Server 2022, you do not have that option. All you can save is like SQL Server will only save one execution plan per query. And let's say the first time you executed the plan, it just gave like 5 records, let's say. It is a parameter sensitive store procedure, let's say. And the first execution gave 5 records, and that used the seek and the key lookup, let's say. But the next time, now that plan will be saved in the cache, right? And next time you run a query which is different parameter, and that will give you 1 million records. And in that case, it still will go ahead and use the same plan in the cache which produced the 5 records. Now imagine how small of a memory grant that is allocated for that 5 records. Now compare with that with the 1 million record. Now that small amount of memory grant is not enough to produce 1 million records, right? So there is a conflict there. So what SQL Server will do is, now I can't do anything. I just have the small plan, which can produce only 5 records versus 1 million records, but I'm using this plan. So I do not know how to process this 1 million records. So I will go ahead and spill all the data to the tempdb, which is like a little trash can that SQL engine will use. Like everybody uses the tempdb. So it will say like, hey, as I do not have memory here, I will go ahead and sort the data in the tempdb, and I will put all the data in the tempdb and blew up the tempdb. So whenever that happens, the query keeps on running. It won't execute that quick because it is using tempdb. It is spilling to the tempdb, and all sort of bad things will happen before you can see the results, and the query will be performing very slow. So this problem is resolved with this particular PSP optimization, where like based upon the number of outputs, it will create up to 3 execution plans, and it will use the execution plans based upon how many records it will produce. Now that's a good advancement. Now the second, like I can show you the demo on this PSP optimization. So I'm using SQL Server 2022 and I'm using AdventureWorks database, AdventureWorks. So before no, why PSP optimization? No, this is a different one. Yeah. So I'm using Stack Overflow database here. Stack Overflow is an old database. So I'm trying to enable the query store. I just restored the old database, so it won't enable the query store automatically. I need to turn it on. So I'm running this query. So query store is already enabled. Now these all are the like the values that you can customize how you wanted to store the data into the query store. So I'm also turning using these particular options. We have talked about there are like 3 operation modes: read, write, read only, and turning it off. So I'm putting it in read, write. Read, write meaning it will read the information as well as write the information into the query store. Now, what is this cleanup policy? Cleanup policy is by default 30 days. After 30 days, it will go ahead and delete the old values, right? Data flush interval in seconds is 15 minutes by default. You can change that as per your needs. Max storage size is 500 MB, but from SQL Server 2019, I believe, they changed it to 1 GB. But 1 GB, depending upon how big your database is, you can allocate the max storage limit for your query store. Interval length in minutes, this is something you need to know. Like every 15 minutes by default, all the grabbed data um, will be saved inside the data file of the database. But this is looking something similar to the flush out interval, right? Where it will capture and then push the data into the data file. But this is a little bit different. Interval length in minutes will every interval will start 15 minutes. So let's say the interval number 0 for 15 minutes. After 15 minutes, interval number 1. And it will be there for 15 minutes, and then interval number 2 will start. So that will repeat, right? In that particular one single interval, 15 minutes, no matter how many times your query will run, let's say there is a store procedure which will run 100 times a minute, let's say. No matter how many times it runs in that particular 15-minute interval, only one record will be saved in the query store, and all the results of it will be aggregated, like average. It will be taken as an average, and only one record will be saved in the query store. Now, why is that? Is because like if it saves every single for every single execution, if it saves one record, then think about 1 GB is not enough, or 2 GB query store size is not enough, right? So for that reason, they take as an interval. And then size based cleanup mode is auto. Um, if you are below SQL Server 2017, go ahead and see. By default, it is not auto mode. It is some other mode, but you need to make sure it changes to auto. Now, when you put the size place cleanup auto, whenever your query store is filled up to 90%, it will go ahead and delete all the old data and until it changes back to 80%. So it will make sure is like save the space before it gets filled up and go to the read only mode. If you do not have this option on, then query store will be filled up and by default it will automatically go to the read only mode. You can't capture any information. So it is not recommended to turn it off. It is always recommended to put it in the auto mode. Now, query capture mode is also auto. When you put it in auto mode, it will only capture the necessary queries, not like the insignificant queries that are running very fast. It won't capture that. And if you ask me like, hey Deepthi, can you share like what are the exact details of what queries will be saved when you choose auto? That is an internal information that Microsoft didn't share. But what they shared is like that query needs to run at least couple of times and it have to hit a CPU limit, a certain CPU limit it have to hit to get captured inside the query store. That is what they mentioned. And max plan per query, how many plans you want to capture per one query, right? And I just put 200 here. This is my demo again. So based upon your needs, you can change that. And wait stats capture mode is enabled from SQL Server 2017 and above. So it will also capture the wait stats. Now I'm going ahead and executing that. Now what we are talking here is like parameter sensitive plan optimization. Now once your database is in SQL Server 2022 mode, this this parameter sensitive plan optimization will automatically be turned on. But I'm just making sure how to do it um, in the T-SQL. Alter database scope configuration, set parameter sensitive plan optimization to be turned on. So I'm going ahead and turning this on the database. Um, and then compatibility mode, we are changing to 2022. And here we are creating a very simple store procedure. If you see, select star from users where reputation is reputation. This is a parameter value, ordering by display name. I'm executing that. Very simple store procedure. Now what I will do is we need to know when I execute this query with different parameters, whether it is creating up to 3 execution plans, right? That is PSP optimization. So before moving further, I would like to show you what are the statistics of the column from the where clause. Like here we are searching on the reputation column. So SQL Server will always check the statistics of that where of that column in the where clause. So we are searching the statistics, how the statistics will SQL Server statistics looks like on that particular column reputation. And in the results, if you see, um, with the stats with this range high key is nothing but the reputation id. With that reputation id 1, you see these many rows, and with the reputation id number 9, these many rows. These are the values of the reputation ids itself and how many rows are there with that particular reputation id. Now I'm taking this information and I bought some ids, where not this one, this one. I took this information, right? And I bought some IDs where I have like varied distribution of the data. So I'm using with 5714 reputation ID. If you see here with 5714, I don't know where it is, but maybe it is like down somewhere. 5714, it should be somewhere here with couple of rows, let's say 5714 or somewhere here. It should be 5714. Did you see this? With this particular reputation ID, we have equal number of rows, only 8 rows here. So I took that ID, I took number 1 ID because number 1 is like, it has most number of records here. So I took that and then I took number 13. The reputation ID 13 have like 13 have like 26,955 rows. Now what I will do is I will go ahead and execute all of them three times, two times, and three times. Let's see the actual execution plan turn on and run this to see the execution plans. Now, if you observe here, index seek, the first one we executed three times, index seek, the same plan, same plan. But for the next one, it took index scan here because, like, if you see for the next, like, anyone have any question?
No, I think I'll mute. No,
Yeah, sure.
yeah, you can go. You can go.
Yeah. So the first three execution only produce 8 rows, 8, and 8. So it choose index seek and key lookup. But for the second execution, which is like reputation ID 1, it did the clustered index scan. If you see here, three times clustered index scan. And the next one as well, like I think we executed for twice, right? So here it used like clustered index scan, and the bottom rows, the bottom ones as well, it used clustered index scan. So that means like we are seeing two execution plans here. So if I go ahead and execute this plan cache, this is a plan cache that I'm trying to see, and execute here, you will see it created the plans. Now, if you see, these are the two plans that we got, like all the different plans that we have in the query store, not the query store, the plan cache. So here, the first one we executed three times. If you see the query here, 323. So when you see the results here in the plan cache, 323. So these are the three plans that got created. The last two plans seem to be the similar ones. Like if you see the previous execution, this execution, the last two plans, these two plans showed similarly, but here they have different plan handles. They are different plan handles. Now, if I want to see the plans, more information about that, right? I can actually execute that query and see like what is the query that was run and what is the query hash. The query hash will be similar because the same query, right? The store procedure is similar. All we changed was the reputation ID we changed. So the query hash itself will not change because it is the same exact store procedure. But query plan hash will change because we got three different plans that we executed with three different IDs. If you see here, um, you can see the exact query. Now, do not worry about this last one because that is a entirely different query that I executed just now. But look at the top three ones. You have the same plan hash. You have the same plan hash here, query hash here, because that is the same exact query. But if you see the plan hash here, two of them are same. If you see here, that means like two of the plans were exactly the same, but the third one is like this one is different. And then you have the plan handles as well. And if you want to see the query plan here, you can click here and see the query plan that we just executed. Now, let me go ahead and execute this other query from the hash, from the plan cache. Yeah, from the plan cache. This gives the same exact query as well, the same kind of information, right? The plan, query plan hash, query hash, and query hash will be the remaining the same because it's store procedure. Plan hash will differ because there are different plans in it. Now, what I wanted to show a little bit here is that this above query will give the same exact results of below query, but I just wanted to show you how the variant plans, what are the variant plans? Variant plans are nothing but the same exact execution plans, but what is a dispatcher plan? How does it looks like, right? Let me execute that and show you. results. Now here, these three, the plans that we saw are the variant plans, but this one is the dispatcher plan. And if you hover your mouse and see how the plan looks like for the dispatcher plan, did you see here? It clearly says multiple plan. It it has the logic in it. You cannot see that information here, but it literally have the logic, and that is the reason it is showing as multiple plans. It consists multiple plans. It cannot store more than three plans. No matter how big your tables are, it will only store three plans based upon the distribution of your data, right? So that's the PSP optimization. That's how it will work. Now let me go back to my slides. Now let's talk a little bit about the memory grant feedback, persistence, and percentile. So before moving further, we will see how the query actually executes on the SQL Server. So whenever the query goes to the execution phase, right? Before going into the execution phase, something known as transformation will happen, meaning like it will create how many type of plans it can create. It will create multiple plans, but then it will go ahead and check for the statistics, SQL Server statistics. One of the statistics we have seen today, it will go ahead and see the distribution of the data within the columns, and then whatever is costing less, it will go ahead and, meaning like costing is not in the dollars, but then the costing is based upon the CPU, memory usage, all of that, right? Whatever is costing less, it will go ahead and save that plan in the plan cache. That plan will be the winner. So it will go ahead and save first. And then it will go ahead and use that plan from the plan cache, and it will allocate the memory grants based upon that cardinality estimate information it gathered while it was creating the cache. So it created a plan, right? So while it builds that plan itself, it will go ahead and um, allocate the memory grant even before the execution. So once it allocates the memory grant, it will go to the execution. Now what if this particular cardinality estimates, meaning the statistics, SQL Server statistics, are out of date? Now if they are out of date, then the memory grant allocated to that particular plan will be also less. Now, if that will happen, like if the cardinality estimates is itself wrong in the first place, like if they're outdated, then the plan that it creates will also be wrong, right? The wrong plan will be saved, and the wrong plan will be used again, and wrong memory grant will be allocated, and it will make a big mess. And the query execution will be affected. It might take long time, or it might throw an error saying like, hey, I can't execute, like 404 error if you are running the query from the application, all because of this one thing going wrong. That if the cardinality estimates, which are like statistics inside your database tables, if those statistics are stale, then this is what will happen. That's how much important the cardinality estimates are. And because memory grants are directly depending upon the cardinality estimates, and memory grants are allocated before the query gets executed, these are really important. Memory grants, feedback, capturing the feedback of the memory grants over time is really important. So, um, with this IQP feature, this is one of the IQP feature in SQL Server 2022. It is all based upon the cardinality estimate, the statistics that we were talking in the previous slide. Based upon those estimates, the memory can be allocated more or less. So the goal with this memory grant feedback is like it will avoid spilling to the temp DB. That is the main goal. If the memory grants are very low, then of course it will go ahead and spill to the temp DB. We do not want that. So with the memory grant feedback, this problem will be resolved. It will always make sure that the results are not spilling to the temp DB. So that way the query will run faster, right? So this memory grant feedback is nothing new. Like it was there from SQL Server 2017, but it was only supported for the batch mode. But with SQL Server 2019 and above, it supported for the row mode as well. So the improvements were like previously, before SQL Server 2022, uh, the memory grant feedback was not saved properly. Like if you restart the SQL Server or if you do the failover to the secondary replica, all of that captured information will be lost. But with SQL Server 2022, even when you do the failover, that information, the memory grant feedback information that is saved will not be lost. That is one of the advancement, and it also persists um, in the query store, because this feature will be using the query store. This information is also saved inside the query store. Now, how the memory grant feedback worked before 2022? It always checked the last execution only. Like, for example, if a query is running and initially it allocated only 5 MB, let's say, but now I'm running the same query with a different execution plan, with a different parameter value, let's say, and that particular execution requires 800 MB, let's say. But since the last time it executed, it only used 5 MB, it will take that 5 MB as a feedback and it will only allocate 5 MB. But do we require that 5 MB or do we require 800 MB? With my current execution, I require 800 MB. But since it is always looking at the feedback, the last feedback, it will use that last feedback as a value to execution, which will only allocate 5 MB when it requires 800 MB. And that will create a mess because that memory is not enough for the SQL Server. And again, it will go to the um, it will spill to the disk and use the tempdb and do all sort of things, and now this memory grant feedback can't handle that, and then it will go ahead and turn it off by itself. This is the situation before SQL Server 2022. And what is the reason? The reason is nothing but it only looked at the last execution data. But with SQL Server 2022, it will persist the data. Like it will not only save the data for last one execution, but it will save the data for multiple executions, and then it will go ahead and monitor the queries to make it consistent. It will always make sure there is enough memory allocated for your queries so that it can avoid spilling to the disk. That is the main advantage of memory grant feedback in SQL Server 2022. Now let's talk a little bit about cardinality estimate feedback. You remember in the previous slides we said like cardinality estimates are nothing but the SQL Server statistics, the statistics which are on your tables. You also need that statistics feedback as well. So there are a couple of techniques that the SQL Server 2022 uses. I'm not going to go in depth because we are running out of time, maybe. But then, like, um, these estimates are changed based upon your execution plan. Let's say your execution plan is you have an execution plan with certain statistics saved in it, right? And then you have another execution plan which is totally different, but the estimates are way too different from the actual number of records you got. Let's say the estimates are showing like you will only get 500 rows, but in actuality when you execute it and when you see the results on the screen, there are 1 million rows. Now the estimates and as well as the actuals are way too different, right? So in that situation, again, the memory will be allocated wrongly and all sort of different things will happen. So in SQL Server 2022, they started making the feedback, taking the feedback of these estimates as well. Now, if the estimates are 10x different, then it will go ahead and monitor those estimates values. And then based upon the feedback, it will automatically go ahead and choose the right execution plan for you. So in order for your queries to be to be selected, there should be the first difference is like there should be a lot of difference between the estimated versus actual. That's when it will actually start looking at that query and it will collect the data, and it will make the model assumptions based upon how many based upon your predicate values, where like it will look at the column, like in the query. If you are using a column value, if you're searching on a where clause, right, it will look at the column statistics of that column which you are searching on in the where clause. It will do that, and it will also make sure like rows, number of rows it can estimate. Based upon all of that values, it will go ahead and identify the queries, verify the feedback, and then replace by using the query hints. So it will use the query hints from the query store automatically for you. It will go ahead and force the plan. It will go ahead and use the query hinting method on your queries. Um, and even this particular IQP feature will use the will use query store. I think this is the last one. No, there is DOP feedback and cardinality estimate feedback. This is the same feedback that we were talking about. All you have to do is you need to make sure your database is on SQL Server 2022 compatibility mode, and your queries have to be repeated. Um, if you expect like a cardinality estimate feedback to be worked on a query which you just runs once in a while, it doesn't work that way. Your queries have to run repeatedly with the persistent plans to make sure we capture this data. And it will, like I said, it will capture that feedback, verify, and it will use the query store hints um, to query store hints to run the queries properly after capturing this feedback. Now let's go ahead and talk a little bit about DOP feedback, which is degree of parallelism feedback. So parallelism, when the parallelism happens in SQL Server is when the SQL Server can't run in a single threaded. It will make use of the CPU, like it will make use of like um, it will use the multiple threads to run your queries, and even this feedback will use the query store data, and it will use something known as like specially designed for query store plan feedbacks. And what it does is it will capture the feedback every time the query runs, and it will always make sure um, it will use the it will use the lowest it will use the lowest max stop value. um, I think it will use up till 4 max stop 4, but it will not go below that. um, Wherever it requires uh, no parallelism, that's when it will take the advantage of DOP feedback. It will not increase the max stop value, but it will always make sure it will decrease the max stop value to save your resources. Again, the query have to be eligible for that. The feedback will be continuously repeated as the query is executing, and then the DOP feedback will be changed. So I believe I covered all of the IQP features, especially like what it does. I'm so sorry I couldn't show you how the query hints work, but I can share you a video here so that you can go ahead and see how it will work. But these are my references that I used to prepare my presentation. And I would like to thank you all one more time. And thank you, Dipankar, for giving me this great opportunity to present at your user group.